How do we factor 15x squared minus 25x to the third by finding the greatest common factor, or what we're going to refer to as the GCF? If we take a look at this first term and look at the coefficient 15, we know that we can break this up into prime numbers, specifically 5 and 3. Now if we take a look at the variables, we see that it's x's squared, meaning that there's two x's. So we can write xx, and I know that now this looks like 5 times 3 times x, and that gives us 15x squared. We're going to find the greatest common factor in a second, but first we need to break down the coefficient of the second term, and 25 breaks down into 5 and 5, right? We've also now got 3 x's, so we can do x, 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 and these are all multiples. So what we need to do now is find the greatest common factor, and I'm going to look at the first term, and I see that we've got 1, 5 here, and we've got 1, 5 here, and now when I'm looking at the x's, I see we've got 1x that are common factors, 2x are common factors, but that's it. So what we're going to do is we're going to pull out, I see the 5, the x, and the x on the left term, and the 5, the x, and the x on the right term. We're going to pull out 5x squared, and then what's remaining in the left term? We've got the 3, we've got the 5, and we've got this x on the right side. So we're going to pull out 5x squared, and it's going to be to what? In the first term, we're left with simply 3. We've got to pull down the negative sign, so it's going to be 3 minus, and then what's left? 5x. So we just factored this expression by finding the greatest common factor. So we're going to need to factor this expression by finding the GCF. We'll start with a little prime factorization looking at the coefficients. So we're going to start with 8. We know that 8 factors into 2 and 4, and then 4 can factor into 2 and 2. 16 factors into 2 and 8, and then 2 and 4, and then 4 factors into 2 and 2, and then finally 24 factors into 2 and 12, 12 factors into 2 and 6, 6 factors into 2 and 3. What about the variables? Well, I see that we've got, in this first term, we've got 2 a's and we've got 3 b's. In the second one, we've got just 1 a and 1 b, and in the third term, we've got 1 a and 2 b's. So we've got a lot on our plate, but we're going to go through right now and identify the GCF. What I like to do is simply go through, and if we're looking at the coefficients, we can see that all 3 have 2 in common, and again another 2, and then finally they all have 2 to the third in common. And what is 2 to the third? 2 to the third is 8. Now let's take a look at the variables. So they all have at least 1a in common, but when we're taking a look at this middle term, right, 16ab, I see that there are no more a's, so at most we can factor out a. Let's take a look at the next one. I see that we've got each term has at least 1b, but again, when we look at this middle term, I can see that because this is b to the first, there are no more b's. So we've got a few things left over. We've got in the first term 1a left over, 1b, 2 b's. We've got 1, 2 left over in the second term, and in the third term we've got 3 and a b. So we just factored this. What is this going to look like? So we just pulled out 8a and what? 1b. Great. So now what we're going to do is we're going to factor each term, and we're going to be thinking about what's left over. So when we're looking in the first term, I can see we have 1a and 2 b's. So that's going to look a little like ab squared plus, well, what's left? I can see simply we've got 2, and there are no variables remaining. We factored out everything but the 2. And then minus what's left. I see we've got this 3, and we've got a b. So minus 3b, close parentheses. Great. So this is our answer. So this is sort of the long way to approach it. If you want to simply eyeball it, if you can factor in your head, for example, I know just looking at this right off the bat, I know that 8 goes into 16 and 24, and I can see that at most there's 2 a's, 1a, 1a. So again, I'm just going to pull out 1a, and again I see this is 1b, so 1b. And then what's left? A, b to the second. I know that 8 times what gives us 16? Well, positive 2. And I know that we already pulled out the variables. We already factored out the variables, so there's nothing left. Minus what? 8 times what? 8 times what gives us negative 24? Well, I know it's negative 3. And then I can also see that we used up the a's, and all we have left is 1b. So that's a more efficient way if you can do that in our head. If that's a little bit of a challenge for you, this is a more thorough but equally sort of comprehensive and effective way of finding the GCF. To factor this expression, we're going to need to approach it by grouping GCFs. So what we're going to do is we're going to split it into this first half because I can see that there is a GCF with 4QR, and I can see there's a GCF with negative QR minus 6. And when we look at this first component, what do they have in common? Clearly they've got 4R. And in the second, negative Q minus 6, we can factor out simply negative 3. And so what does that look like? Well, what's remaining in this first half? So we can write it like this. All right. Well, what's left? When we factor out 4QR, we're left with simply Q plus what? 2. Because 4 times Q is going to give us 4Q, and 4R times Q gives us 4QR, and 4R times 2 is going to give us 8R. What about here? Negative 3 times what gives us negative 3Q? Simply Q, and then negative 3 times what gives us negative 6? Positive 2. Great. So now what I know, when we take a look at this, in blue we can factor out the Q plus 2. And to do that, I'm going to write Q plus 2. Great. And now we're going to combine or factor together 4R and minus 3. And when we do, that gives us 4R minus 3, very simply. And this is our answer. We just factored this by grouping. We're also going to factor this expression by grouping, and we're going to start with the second half first, and then we're going to factor the first two terms. And when we're looking at 4n minus 20, I can see that only the first term has an n, so we're not going to be factoring a variable. We are going to be factoring 4, because I know that 4 is a factor of 4 and 20, and when we do factor 4, that's going to give us what? That leaves us with n minus 5. Great. And what is the GCF of negative 3 NP plus positive 15P? Well, I know that 3 goes into both negative 3 and positive 15, and I can see that both have P's. So we're going to be either factoring positive 3P or negative 3P. We're going to factor negative 3P because we want this sign to flip, and you'll see in just 1 second what that's going to look like. So we factored out negative 3P, and when we do, that leaves us with what? Well, we've got now left simply n, and the sign flips when we factor out negative 3. Negative 3 times what gives us positive 15? Negative 5, because a negative times a negative is a positive. And so now we're left with this expression. We can now factor out the n minus 5. So we've got n minus 5 times what? We'll factor together the negative 3P plus 4, and this, ladies and gentlemen, is our answer, factored by grouping. To factor this trinomial, we're going to need to figure out which two numbers multiply to give us negative 24 and add to give us negative 2. So let's determine the pairs that are going to give us 24 or negative 24. So I know right off the bat, right, it's going to be 24 and 1. I also know it's going to be 12 and 2. I know it's going to be 3 and 8 and 4 and 6. And I know in each instance, because this is negative, right, it's going to be either positive 24 and negative 1, or negative 24 and positive 1, and so on and so forth. So when I'm sort of approaching this, I now need to think, all right, of these pairs of numbers, and there are 4, which will add or subtract to give us 2 or negative 2. So I know there's no combination of positive or negative 24 and positive negative 1 that's going to give us 2. So I'm going to actually just nix that. Same can be said for 12, because positive 12 minus 2 is going to give us positive 10. And likewise for the rest of those combinations. Same things with 3 and 8. So now what we're left with is a combination of positive 4 and negative 6, or negative 4 and positive 6. So we're thinking about this pair, and I know that negative 6 plus positive 4 will give us negative 2. So this is our shortcut to approaching this kind of problem. We're going to create two sets of parentheses, and I can see that it's always going to be x something times x something, because it starts off with x squared, and x times x is x squared. And now what we're going to be doing is multiplying, or it's going to be x plus 4 times x minus 6. And now we can check, so we can see exactly what that looks like. So I know that x times x is going to give us x squared. X times negative 6 is going to give us negative x6. 4 times x is going to give us positive 4x. And then finally, we're foiling, right? 4 times negative 6 is going to give us negative 24. And now we can simplify. We've got x squared. And now negative 6x plus 4x is going to give us minus 2x minus 24. And that matches it. This, ladies and gentlemen, is factored completely. We checked our answers. So this right here is our answer. So we're going to be solving this equation by factoring, and it's equal to 0. So we're going to be looking for the value of these x's. In this case, we're going to be referring to them as the roots. And I also know, looking at this, this equation, that we've got a GCF right off the bat. We're going to be able to factor out the negative 2, obviously from this first term, but also from negative 6 and positive 140. What's that going to look like? Well, if we factor out negative 2, we're now left with x squared plus 3x minus negative 2 times what gives us positive 140? 70. Great. Equals 0. Beautiful. Now, like in the similar scenario, we're looking at this trinomial on the interior of this parentheses, and we're going to need to figure out which two numbers multiply to give us negative 70, but also add to give us positive 3. So what are some of those options? Well, because this is a negative, I know that it's going to be a combination of a negative and a positive number. So it could be 1 and 70, 2 and 35, 3 and anything, no, but 5 and 14, or, negative 5, positive 14, negative 5, positive 14, or positive 5, negative 14, and also 7 and 10. And I'm looking at it, I know that one of these pairs have got to add to give us positive 3, and I know that 1 and 70, there's no combination that can give us 3. Likewise for 2 and 35, or 5 and 14. So we're left with this combination, 7 and 10, specifically positive 7, negative 10, or negative 7, positive 10. Great. So which combination is going to give us positive 3? I know right off the bat that's going to be positive 10 and negative 7, because 10 minus 7 is going to give us positive 3. Great. So let's zoom out a little bit to give ourselves some space. And I know that now is going to look like negative 2, open parentheses, close parentheses, open parentheses, close parentheses, x, x. Great. So what's going to go in here? We just determined that it's going to be positive 10 minus 7. And we've always got to carry down the negative 0. We don't want to forget that because that's our objective in this scenario. And so now let's check our work. I know that we're going to FOIL. And when we do, I can see that x times x is x squared. X times negative 7 is negative 7x. 10 times x is positive 10x. And then 10 times negative 7 is negative 70. And does that match what we had earlier? Almost. We got to simplify a little bit further. X squared, 10x minus 7x is going to give us positive 3x minus 70. And it does match. That is exactly what we had earlier. Great. So what does that mean? So now we're left with this, and we are not done, ladies and gentlemen. We're not there yet. We're super close. So I'm actually going to rewrite this, and we're only concerned with right now the x plus 10 in this parentheses and x minus 7 as it relates to these being equal to 0, because we're trying to figure out what the value of x is. So what I'm going to do is I'm going to write x plus 10 equals 0, and I'll write x minus 7 equals 0. Great. So again, we simply took what was inside these parentheses, because we now need to figure out what the value of x is. We're going to do a little inverse operation. We're going to subtract 10 from both sides, and when we do, in the first half, x equals negative 10, and in the second half, x minus 7, we're going to add 7 to both sides, and now we're left with x equals positive 7. So this, ladies and gentlemen, this is our roots. This is the answer, and if